The next way that we want to describe a graph of a function or the graph of any kind of relation is that we want to describe its maximum and minimum values. Now, when we looked at the last topic, when we were looking at increase, decrease, constant, remember we said that we were going to answer with x's only. This time when we answer, we want to answer as an actual ordered pair. Okay, so keep that in mind, that the way we answer the different things will be different. All right, so when we talk about a maximum and a minimum, most of the time that kind of makes sense. The maximum is a high point, a minimum is a low point. Now, most people get confused kind of in two different ways. One way that people get confused is by saying, oh, a maximum, it must be the highest point. Well, not necessarily. A maximum is any point where I change from increasing to decreasing. So remember the increase, decrease, constant that we were just doing. Anytime I'm going and I increase, there's a point where I change to decrease. That point right there will be a maximum. The question is it the highest point or is it just a relatively high point in the graph? And we'll get to that here in just a minute. When I look at a minimum point, that's going to be where I'm decreasing, and then I change to increasing. That point right there is what we call a minimum. Again, I want to say, okay, is it absolutely the lowest point of the entire graph, or is it just relatively, it's just a change in direction? So that's what we talk about when we discuss this idea of absolute and relative. Absolute means that if I look at the entire graph from one end to the next, it is absolutely the highest or absolutely the lowest. When we talk about anything relative, it's basically anything that's not absolute. Okay, so anytime we change direction from increase to decrease and we have a maximum, it's considered relative unless it is the absolute. Okay, pretty much like when we were talking about functions. Everything is a relation unless it's further a function. Okay, so that's kind of what we're talking about. Now, the next place that people kind of get a little bit confused or they mix up is when we talk about an end point. The end point of a graph is actually nothing. It means nothing in terms of maximum and minimums because it doesn't change direction. It starts or ends a direction. Okay, the only thing that it could do is it could eliminate an absolute value, meaning that if I have an end that goes off to infinity, I would never be able to have an absolute to that graph. So I have an example here just already labeled. So I noticed that in my first one, A, this point is nothing because it's an end point. When I look at point B, it's going to be a relative maximum because there are other higher points, but it does change direction from increase to decrease. Okay. Then we see we have a relative minimum here at C because, again, it's not the lowest point. Remember, A is lower. Even though it's not a max or a min, it is a lower value. So therefore, it's just a relative minimum here because I change from decrease to increase, right? Then I get up here to this point D. And at first we would say, okay, it's a relative max. No, actually, it's the absolute maximum because it is absolutely the highest point. Then when I get to E, it's an endpoint, so it's nothing again. Okay, so we're going to do that, label our maximum mins. We're actually now going to give it values. So in the last one, there was no X and Y axis counting on it. But when we look at these next two examples, we'll actually give it the ordered pair. So looking at this first example, I see the first point here is at 1, 2, 3, 4, 5, -5, 1. Okay, and that changes direction from increasing to decreasing. So that is going to be a maximum. The question is it a relative maximum or is it an absolute? So I look at the entire graph, there's a higher point, so we're going to call this a relative maximum, okay, a relative maximum. So I keep going on this graph and I notice, oh, here at the bottom, I'm changing from decreasing to increasing. That's going to be at the point -3, -2. And I'm changing from decrease to increase, so that's going to be a minimum. The question is it a relative or absolute? So I look here, the end values are arrows, so that's going to go on to infinity. So even though those don't count as far as a max or a min, they do exclude this one from being absolute. So this is just going to be, again, a relative minimum. All right, keeping on going through the graph, I'm going increasing. Now I'm going to change to decreasing. I'm changing at the point 0, 3. And I know since I'm going from increase to decrease that that's going to be a maximum. The question is it absolute or relative? I look at the whole graph. This is actually absolute maximum. Okay, still going on this graph, I go from decreasing to increasing, which means we're going to have some sort of a minimum here at 2, 0. And I notice, okay, well, that's going to be a relative minimum because there's definitely lower points. Continuing on, I go from increase to decrease. At this point, 4, 1, I'm going to have a maximum. And it's got to be relative because I already have an absolute. Remember, absolute means the highest or the lowest point. There's no tying here. If both of them are equal, then they're both relative, okay? So now that we've labeled our maximum and minimums, absolute versus relative there, let's see if we can do that same thing for this next problem, okay? So I start off, again, that's an endpoint, so nothing's going to happen there. I'm going from decreasing, I change to increasing. So at that point, -2, 0, I'm going to have a minimum. So what kind of minimum? Well, it ties to be the lowest point, but it's tying. So actually that's going to be relative because I can't have any ties, okay? So now I'm going to change from increasing to decreasing. That change occurs at 0, 3, which means I'm going to have a maximum. But if I look at the entire graph, these end values are higher, so this is going to make this a relative maximum. I'm changing from decreasing to increasing, so at this point, 2, 0, I'm going to have a minimum. Again, since it tied to be the lowest with the other minimum, it's going to be relative. And then as I keep going, even though I stop, that's an endpoint, so that is nothing. Okay, so we notice we could have graphs that have no absolute max or min. I could have graphs that have only one absolute max or min. I could have multiple relative max and mins, but if I have an absolute, it would only be one absolute max and maybe one absolute min.